The next step is to define loads. So in our case, we're going to have 3 loads. The first one will be here, force. The second one will be here, bearing load. And here it's going to be pressure. To add a load, we have to go here to external loads. We can right click on it, and here we have our loads. We can divide loads into 2 major groups: structural loads here and thermal flow loads, this one. In our case, we're going to use only structural loads. So let's first start with force. Let's click on the force. The forces can be applied to any vertex or any point, joint, beam, edge, face, or plane. So we can go with the mouse here. As you see, we can go to any face, surface, edge, vertex, so anywhere where we want. As well, here we can go to split, and we can define the region where we're gonna apply a load here. But we did that before we start analysis. So let's go to type. So here we can choose direction of the load. We can go with normal direction and selected direction. So we can choose here if we want face, edge, plane for direction. Let's go with normal. Here we have to choose our units. We go with SI units. And here we go with the force value. And we're gonna have 2000 newtons, like this. And we're gonna choose this face and this face. And now here down we have per item or total. So now we have 2000 on this face and 2000 on this face. And this is not what we want. We want that on both faces will be 2000. So let's go with total. And now we have 2000 newtons on both faces. Here we can also change direction. Now we have here the Y direction. And let's go. Let's uncheck direction because our force must be directed here, down. Here also we can go to symbol settings and change the color if we want. Let's click OK. And now, as we see, we added force 1 with a 2000 newtons. And this is here. We can also right click here. We can hide if we want. Let's show. We can suppress. We can go edit definition, we can copy, delete, and so on. So let's right click on the external loads. So we have here a torque. Let's click on the torque. So torque can be applied to faces, circular or cylindrical or beams. So we can go with mouse here and we can choose here faces, circular or cylindrical. Here we have torque value and SI units. But in our case, we won't use torque, but if you need, it's easy to apply torque. Let's exit. Let's right click and let's go to pressure. So the pressure can be applied to any face of a solid body or a shell. So we can go with mouse here and we can apply to any face, any surface that we want. And we're gonna apply pressure on this surface here. Let's click here. And let's choose normal to selected face. We can also use reference geometry, but we're gonna go with normal. Here we have units. Let's leave it Newton per meter squared. And the pressure value will be 1500. Okay. Let's click OK. And now we can see that we have here pressure. Okay, we didn't put the right value. Let's go right click, edit definition, and we have 1500 like this, and now it's correct. And now we have here the force and pressure. Let's go to external loads, right click. Here we have gravity. So the gravity property manager applies linear accelerations which is distributed over the entire volume of the body. So the direction of the acceleration can be parallel to the 3 coordinate axis or to selected edge. Here we have face, edge, plane for direction. And by the default, the value of acceleration is 9.81 meter per second squared. And here we can see the symbol gravity. But in our case, we won't use gravity, so let's exit. If you need it, you can easily apply. Let's right click on the external loads and let's go with centrifugal. The centrifugal property manager applies angular velocity and acceleration to the body. So the model spins around the specified axis. Here you can choose the selected reference, axis, edge, or cylindrical face for direction. Here you can choose angular velocity and angular acceleration. Let's exit. Let's right click and let's define bearing load. Let's click here. So the bearing loads can be applied to cylindrical faces or edges of circular shells. So we're gonna apply our load here. Let's click on this surface like this. And here we have to define coordinate system. Let's click here. Let's open our tree and let's click on the coordinate system 1. Here, the units SI. Here we have direction X, but we're gonna go with Y direction like this. And let's put here the value of 2000 like this. And here we go with sinusoidal distribution. Now we can click OK. Now we have a message that our direction is not good. Let's click OK. Now let's click here, reverse direction. As you see, we go up, we have to go down. It's not possible to go up, so we have to go down. So we have to click here, reverse direction, like this. And let's click OK. And now we have added force, pressure, and bearing load. But let's look on other loads. Let's right click. Here we have temperature. So temperature can be prescribed to faces, edges, and vertices. Here we have flow effects, thermal effects, and here we have remote load mass. Remote load mass is used to define forces, moments, and masses that are suppressed or not defined in the geometric model. The forces and the moments are applied at remote location, and these remote entities are outside of the model. And here we have distributed mass. This function is used to simulate the effect of the bodies that are suppressed or not included in the modeling when their mass can be assumed to be uniformly distributed on the specific faces. So it is assumed that the suppressed body lies directly on the selected faces, so rotational effects are not considered. And those are all laws that we have here, and we're going to use force, pressure, and bearing loads, and those are the most common. And now if we look here on the tree, we define the material, fixture, external loads, and the next step is to define mesh.